Hi, this is everything you've always wanted to know about exponents, but were afraid to ask. I'm John Linneball from John Linneball Tutoring, and here's my website and my email and my phone number if you'd like to contact me about anything in this video or anything to do with tutoring. So, what's an exponent? I'm glad you asked. An exponent is the power to which a number called the base is raised. In other words, you take the number that's the base and you multiply itself by itself the number of times that the power says. So for example, 2 to the third power, here's the base is 2, the exponent is 3, we call that 2 to the third power, or 2 cubed. 2 is the base, 3 is the exponent or power, which means we multiply the base by itself the power number of times. So 2 cubed is equal to 2 times 2 times 2, which is 8. Sorry, this is a little out of order, but first things first, b to the 1 equals b. Why? Because it's b one time. And b to the 0 is equal to 1. Anything to the 0 power is equal to 1. Don't worry, we'll discuss that in a few minutes. Boom! Avoid the SAT or ACT trap of the sucker punch answer. What do I mean? Well, a sucker punch answer is a distractor answer that looks right. It's usually choice A, that you pick before you've really fully thought it through, and you don't realize you've made a mistake until you get the test results back and realize you've gotten it wrong and that it was a dumb choice. So you want to read all the answer choices before picking choice A, or any choice. You want to avoid the sucker punch answer. A few sucker punch answers you might see are anything that ignores the fact that 0 to any power is 0. Why? Because 0 times anything is 0. 0 to the 0 power is undefined. It can't be 1 since 0 times anything is 0, and it can't be 0 since we add exponents when we multiply. How do we multiply exponents? Well, the first thing that we do is remember that b to the 1 is always equal to b, and b to the 0 is equal to 1. So a to the b times a to the c is equal to a to the b plus c. Well, why? Well, let's take our 2 cubed and 2 squared example again. Remember, 2 cubed is equal to 2 times 2 times 2, because it's 2 to the third power. And 2 squared is just equal to 2 times 2, because it's equal to 2 to the second power. So 2 cubed times 2 squared is just going to be 2 times 2 times 2 times 2 times 2. And by the associative property, we can remove the parentheses, so we just get 2 times 2 times 2 times 2 times 2. Notice that there are 5 2's here. That means it's equal to 2 to the 5th, which is equal to 2 to the 3 plus 2. Raising a power to a power. A to the b to the c power is equal to a to the b times c power. Why? Well, again, let's take the same numbers that we've used before. 2 cubed, and we're going to take that to the second power. We're going to square it. So we have 2 times 2 times 2, and we're multiplying by itself. So it's going to be 2 times 2 times 2 times 2 times 2 times 2 times 2, which is 2 times itself 6 times, which is equal to 2 to the 6. So it's a times itself a number of times, then that number, a to whatever power, then that number, say a to the third power, is multiplied by itself the same number of times. So again, returning to our example with 2's, 2 to the third squared is 2 to the 6th power, not 2 to the 5th power. So when we move on here, how do powers relate to multiplication? The distributive property of exponentiation over multiplication is pretty easy to learn. Unfortunately, when it's explained in terms like this, we have a hard time. So let's move on to seeing it in more mathematical terms rather than written in English. A times b to the c power is equal to a to the c power times b to the c power. Why is that? Well, because we have a times itself c times, and we have b times itself c times. So we can see that this is just going to be equal to AB, 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 C number of times, and then you can just break that up using the same associative property we used with 2 before. So 2 times 3 to the 4th power is equal to 1296. How do we know that? Because it's 2 to the 4th times 3 to the 4th, which is 16 times 81, which is 1296. And if you're still skeptical, you'll say, John, I don't believe you. Why don't you do what's in the parentheses first? Fine, be that way. 2 times 3 is 6. We put 6 into our calculator. We're going to raise 6 to the 4th power. We get 1296. So there you go. All right. How about division? I'm glad you asked. A over b to the c power is a to the c over b to the c, which is 2/3 to the fourth. We can make that 0.66666. We can take our calculator and go 2 divided by 3, 0.666666667, and we can take that to the fourth power, and we end up with 0.197380064, blah, 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 repeating ugly decimal. Okay, so hey, this looks exactly like what happens when we multiply and take a product to a power. There's a reason, because division is just multiplying by the reciprocal. So dividing by a is really the same as multiplying by 1 over a, as I'm sure you learned with fractions. All right, so you're asking, hey, John, you promised to explain why anything to the 0 power is 1. I'm glad you asked. The reason that something to the 0 power is 1 is because if we take a number to the a plus b power, we know that's equal to a, the number to the a multiplied by or times the number to the b power. So what if b equals 0? Well, then we just have the number to the a power. So plugging in numbers, 2 to the 3 plus 0 is equal to 2 to the 3, which is 2 cubed, since 3 plus 0 equals 0. It's also 2 to the 3 times 2 to the 0 from above. So since 2 to the 3 times 2 to the 0 equals 2 to the 3, then 2 to the 0 has to be equal to 1, since we know if we multiply it, that it has to work out that way, because 3 plus 0 is 3, and 2 cubed times anything that gives you 2 cubed, that means this thing here has to be equal to 1, because we know that anything times 1 is equal to itself. So anytime you multiply a number by a mystery number and the result is the same number you started with, then the mystery number has to be equal to 1. Does that make sense? 1 is also known as the multiplicative identity. But anyway, let's move on. Remember, 0 to the 0 power is undefined. It can't be 1 since 0 times anything is 0, and it can't be 0 since we add exponents when we multiply. So it's undefined. Anything that gives you 0 to the 0 in an SAT or ACT answer is automatically wrong. All right, you might also be asking, hey, why is the second power called squared or the square of? Well, when you take the area of an actual geometric square, the way you find the area is you take the side length and you square it. So if this is 5 and that's 5, the area is 25. So in this case, it's 5 centimeters times 5 centimeters, which is 25 square centimeters, or 5 squared centimeters if you like. So why is the third power called cubed or the cube of? It's basically the same idea. When you take the volume of a cube, you have to multiply the height times the width times the depth. In this case, we have a cube with edge length 5, so it's going to be 5 times 5 times 5. 5 times 5 times 5 equals 125, which is 5 to the third power, which is 5 cubed. So what's a number to a negative power? Glad you asked. For example, a to the negative b power is equal to 1 over a to the b, or 2 to the negative 3, for example, is equal to 1 over 2 to the third, which is 1 over 2 cubed, which is 1 over 8. So, great. What's a number to a fractional power? It's that root of the number. For example, 2 to the 1/2 power is just the square root of 2. 2 to the 1/3 power is equal to the cube root of 2. That is the third root of 2. Now for an SAT trick question. What is the last digit in 2 to the 2016? Well, you can't use a calculator. The number's too big. Don't believe me? Try to do it. Get out my handy-dandy Windows calculator. We'll clear it out to make sure there's nothing lurking in there. So we have 2 to the 2016. Golly gee, that's going to say it's 7.524 blah, 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 blah. E to the 606, so it's 7, some big long decimal to the 10 to the 606th power. Boy, that's not going to help, is it? Well, we could say maybe it ends in a 1. I don't know. I don't think that's right for a power of 2. How do I know it's not right? Well, simple. There's a pattern to powers of 2. 2 to the 1 equals 2, 2 to the 2 equals 4, 2 to the 3 equals 8, 2 to the 4 is 16, 2 to the 5th is 32, 2 to the 6th is 64, 2 to the 7th is 128, 2 to the 8 is 256. Hey, 2 to the 12th is 4092, then 2 to the 5th is also ends in a 2, 2 to the 9th ends in a 2, and 2 squared is a 4, and 2 to the 6th is 64, 2 to the 10th is 1024. I get it. It repeats every fourth one. So 1, 2, 3, 4. So what do? Then what we do is we use long division. The last digit repeats every 4 numbers, as I just said. So remember 4th grade math when you learned long division with remainders before you learned how to do the decimal part of it? Just divide the exponent by 4. If it divides with no remainder, that is, it goes in evenly, then the last digit is 6. Remember, 2 to the 4th is 16, 2 to the 8th is 256. Otherwise, if the remainder is equal to 1, the digit's 2. If the remainder is equal to 2, it's equal to 4. Remainder is equal to 3, last digit is equal to 8. So all you can do is just write these things out. Hopefully you'll know your powers of 2 up to about 10 anyway, and just see the pattern. So, can we test this? You bet. Let's take a number that we can actually check, but still pretty big. So here's 2. We're going to take it to the 64th power. We get whatever that is, it ends in a 6. That's 18 to a very large power of 10. So, well, let's see. We can say, all right, that's 100,000s, that's millions, that's billions, that's trillions, that's quadrillions, so 18 quintillion, I believe that is. Anyway, hooray! Once we figured that out, we see 64 over 4 equals 16, so there's no remainder, so our method would say the last digit is equal to 6. And now back to the original problem. 2016 over 4 equals 504. We can check that using the calculator here. And all right, let's get my application and my calculator. So that is 2016 over 4 is equal to 504, so there's no remainder. So the last digit is equal to 6 in 2016, or 2 to the 2016. Boy, sometimes you just can't talk very clearly. Anyway, so that's a neat trick. They often have that on the ACT or the SAT. So I hope this video has been helpful to you. If you have any questions, please, you can leave a comment below, you can email me, or you can call me, or whatever. If you like what I'm doing, please subscribe, please like my videos. Thanks. Have a nice day.